Hello everyone, and welcome to our universe. Today we'll be talking about the gravity on other planets. So gravity is a very fundamental force in physics, and it's one that we take for granted on the planet Earth. But it's something that we just generally don't think about. We think that gravity is pretty much constant everywhere in the universe. Having only lived on one planet, humans are pretty much used to the Earth's environment. Gravity is measured in Gs, so therefore it's quite easy to categorize Earth as just a steady 1g, or you can call it 9.8 meters per second squared. However, if you would go into space, or set foot on the moon, the gravity would be very different, and something that Earthlings would not be used to. So putting it in layman's terms, gravity is dependent on mass. From stars, planets, galaxies, and even subatomic particles, gravity seems to rely on just one thing. The mass, though, can be categorized in three different ways: its size, mass, and density. And this is what gives the object gravity. When it comes to the planets in our solar system, there is various size, density, and masses, and therefore the strength of the gravity on the surfaces can vary dramatically. So let's start off with the Earth's gravity. As noted before, it was 9.8 meters per second squared. This means that if you held an object and let go of it, it would accelerate towards the surface at a speed of 9.8 meters every second from the freefall. This is a standard measurement to know the gravitational pull of a planet, and we express this in what's known as a single G. Isaac Newton's universal gravitational law states that two bodies can be expressed mathematically as a formula of a force, where F is the force, m1 and m2 are the masses of the objects interacting, and r is the distance between the centers of the object. There is also a gravitational constant. So now that we know how to mathematically figure it out, and use experimentation to prove this, let's see exactly how the gravity compares to the other planets in the solar system. So let's start off with Mercury. It has a mean radius of 2,440 kilometers and has a mass of 3.3 times 10 to the 23 kilograms. Mercury is only around about a third of the size of Earth. This makes Mercury the smallest and least massive planet in the solar system. However, it does have a high density, and this is just slightly lower than the Earth's density. Mercury has a surface gravity of 3.7 meters per second squared. So if you do the calculation, that's the equivalent of 0.38 g. So what's the gravity like on Venus? So Venus is a very similar planet to Earth, and it's often known as the Earth's twin. Venus has a radius of just over 6,000 kilometers, and has a mass of 4.87 times 10 to the 24 kilograms. And as you can see, it's pretty much the same size as Earth, but just a tiny bit smaller. It again has around about the same density, but because of the lower density, the gravity changes. This comes out at 8.87 meters per second squared. This means that the gravity on Venus is just lower than Earth's, at 0.91 g. So what's the gravity on the Moon? The Moon is of course the only astronomical body where human beings are being able to test out gravity in person. So the Moon is a very small object, at around 1,700 kilometers in radius. Its mass is 7.35 times 10 to the 22 kilograms, and of course it's only about the size of the United States. Because of its size and mass, it also has a low density. This means that the gravity is only 1.62 meters per second squared, so the gravity is very low, at 0.17. This gives a great reason why the astronauts on the Apollo missions were jumping around like they were on a trampoline. It also gave them a great excuse to experiment on the gravity of the Moon, so you can do certain things on the surface of the Moon that you could never do on the surface of the Earth. So what about Mars? Its size, mass, and density are very small compared to our home planet. It has a radius of over 3,000 kilometers, and has a mass of 6.42 times 10 to the 23 kilograms. But of course, it's a lot smaller than Earth. With this, it comes with a lower density, and therefore its gravity is lower as well, at 3.72 meters per second squared. So if you calculate it, it comes out to 0.38 g, which again is actually closer to the gravity on the Moon than it is to Earth. So what about the king of the planets, Jupiter? Well, Jupiter is just under 70,000 kilometers in radius, and has a mass of 1.9 times 10 to the 27 kilograms. And of course, because it's the giant of the solar system, it completely dwarfs the Earth and all of the inner planets. But because it's mainly made out of gas, it has a much lower density, and therefore because of its considerable size, it doesn't have a higher g than you'd expect. It only comes out at 24.75 meters per second squared. This means that Jupiter's gravity is only 2.53. That's only 2.5 times the strength of Earth, even though Jupiter's mass is over 320 times that of the Earth. So what's the gravity like on Saturn? Well, like Jupiter, Saturn is a very similar planet. At just under 60,000 kilometers, this is the second biggest planet in the solar system, and has a mass of 5.69 times 10 to the 26 kilograms. And of course, it dwarfs all of the inner planets put together. But again, it falls short like Jupiter because of its composition. This means that its gravity is only 10.44 meters per second squared. And surprisingly, it has near enough the same g as Earth does, at 1.07. So now we come to the outer solar system. This is the realm of the icy giants. So let's start with Uranus, or Uranus, whichever one you fancy. Uranus is the third largest planet in the solar system, at just over 25,000 kilometers. It has a mass of 8.68 times 10 to the 25 kilograms. And of course, it's just over 4 times the size of Earth, so again, this is still a very large planet. But like the other gas giant, Uranus falls short on density, so this means that it's only 8.69 meters per second squared. So therefore, it comes out at lower than 1 g, at 0.87. And finally, we come to the furthest planet from the Sun, Neptune. Sorry about that, Pluto. Neptune is just under 25,000 kilometers, making it the fourth largest planet. It has a mass of 1.03 times 10 to the 26 kilograms. And again, it's a very similar size to Uranus. Neptune is a very similar planet to Uranus, not only in mass and size, but also in density. But it does have a higher gravity, at 11.15 meters per second squared. This means that it actually goes higher than Earth, at 1.14 g. So it doesn't quite matter if you're on the surface of Mercury, the surface of Mars, or the clouds of Jupiter. Gravity basically determines the size, the mass, and density of all the planets and our Sun. It also seems to figure out the formation of our solar system and the orbits of the planets. Understanding the effect of gravity, or zero G, on the human body is essential for space travel, especially when you're going for long duration missions, like to the International Space Station, the Moon, or possibly even Mars. Knowing how strong the gravity is on other planets could help us understand more about gravity itself, because understanding the gravity of a planet basically relies on 3 things: its mass, its size, and its density.